Okay, let's do some anatomy of the spinal cord. What I have here are a few pictures I like to start with. Obviously, over here on the left, obviously, this is the brain over here on the left, and this attachment right here should probably be a little bit more structured. But what you see here are the vertebra, and you see how the vertebra are surrounding the spinal cord. Notice how the spinal cord ends right here about L1, L2. It's higher than you think. And so what ends up happening here is that the spinal cord kind of tapers, and that tapering is called the conus medullaris. Now, you can also see that down here, these are all basically nerves extending from the spinal cord, right? The spinal cord doesn't extend past L1, L2. And all of these nerves are called the cauda equina, which means tail of horse. Cauda means tail. So those are some macro anatomical structures that you can see with the spinal cord itself. But I also want to remind you that we're not talking about the vertebral column here, right? The vertebral column has vertebra that are stacked up against each other, and that's what these structures are right here and right here. So remember, the spinal cord runs in the center of the vertebral foramen, the big hole. And so as these vertebrae are stacked up, they provide support and protection. So remember that this view that we're looking at right here with the vertebra, this view would be a superior view, right? We're looking top down at one vertebra. And I will refer back to this in just a moment. So there are some meninges, which are basically just connective tissue sheaths that surround the spinal cord itself. These would be akin to the epimysium, paramysium, endomysium of muscles, or the epineurium, perineurium, or endoneurium of nerves. So, surrounding the spine is this very, very light, very thin, very delicate, and I'm going to draw it right here, this very delicate lining that is called the pia, and I'm going to do some numbers up here. So number 1, and that's what this is, number 1, is what's called the pia mater. So this means soft mother or soft surrounding. On top of the pia mater is another mater, and that mater is called the, and this is number 2, that mater is called something else. No, I'm kidding, I'm sorry. It's called the arachnoid, which means spider. And so this is not like tights or like a stocking. This is more like a fishnet stocking. It has a web in it. There's another mater, which is the outermost mater, and that's this thicker one. And let's draw this even thicker. So that's this thicker one that's right here, and we'll call that number 3, and that was what is called the dura mater, which means tough mother. And so this is on the outside. In between each of these are fluid-filled or structure-filled space. Just to round out the drawing, I am going to draw the bone around it because there is vertebral bone that is on top of the dura mater. So let's look at some of the spaces in here. Number 4, this is the space between the pia and the arachnoid mater. And that space is called the sub, because it is deep or underneath, subarachnoid space. This is the space that's full of spinal fluid. This is the space that you inject general anesthesia. General. I want it to go all throughout your spine, put you to sleep, and make you completely submissive during surgery. The next space, number 5, is called the subdural space. It's usually at this point that students say, what about the subpia? There is no space between the pia mater and the spinal cord itself. The pia mater actually not only sticks to the spinal cord, but it does dip into some of these crevices. So number 5 is the subdural space. This is a space where there are a lot of blood vessels, and you may know the term subdural hematoma. That is a blood clot in this subdural space. Between the bone and the dura mater is number 6, and this would be the epidural space. This is filled with fat. And if we inject an anesthetic into this epidural space, it will go up and down from where it's injected, but it won't really be circulated all throughout the entire spine because it's only injected into the fat at a certain place. Okay, let's keep going. So, this structure right here, which is number 7, this is the posterior medial or median sulcus. A sulcus is like a valley, and this is the posterior median sulcus. And so that tells me that this side here is posterior. Let's label that. Let's also label this over here anterior. When we start talking about the spine, we actually abandon these two words, posterior and anterior, and we use dorsal, which means back, and we use ventral, which means belly. Okay, so that oriented us a little bit because we have a superior view here. We're looking top down, and now we know that that is posterior. So let's do number 8, which is this hole right here. And this hole is called the central canal. There is also cerebrospinal fluid floating through the central canal. In fact, CSF descends the central canal and then ascends through the arachnoid, the subarachnoid space. So it's like it recycles itself back up and back down and back up and back down. Okay, let's keep going. Let's do a number 9. Is that what I want to do? No, yes, sorry. This is number 9 right here. This big, huge fissure. This is not a sulcus. A sulcus is just a valley. A fissure is like an open earthquake fault. It's widened even more, and this is called the anterior median fissure. So looking for the posterior median sulcus, locating the anterior median fissure, that will help us realize what is anterior and what is posterior on a picture like this. All right, let's dig into just structural names of the gray matter, because the first thing that you see is that there's this like butterfly outline on either side of the spinal column here, and so this is gray matter. In fact, let's give it a little bit of a, oh, that does nothing to it. Let's give it a little bit of a gray color, because this is gray matter right here, and everything that's outside is white matter. I'm not going to color fully in the other side, but this is also gray matter. Now, gray matter, the amount of it is different at different levels of the spinal column. So I just want you to be aware of that. The butterfly can look different in the lumbar than it does from the thoracic. And actually, this one does come from a lumbar cut. So that's what that is. All right, let's use green here. And what I'm going to do is I'm going to label 10, 11, and 12 all at once. So this area right here, the top of the butterfly's wing, is 10. This little tiny projection, you can almost not see it, but there is a little tiny projection there. And we're going to label that 11, and then we're going to label the bottom of the butterfly wing 12. These are called gray matter horns, right? So not projections, we call these horns. And there is the posterior horn, right? Because that's toward the posterior or the back. This can be called the dorsal horn too. There's a lateral horn, which is huge in the thoracic section, but not very big here. And there's also an anterior horn. So, if you refer to gray matter in the spinal cord, I will put a note on any of your case study answers and I'll say, what gray matter? There's a lot of it, right? And this is how you can be more specific. You can say a gray matter in the spinal cord by the posterior gray matter horn. So these are just locational terms. In fact, gray matter horns tell you nothing about what gray matter does. Let's do the same for our white matter, actually. White matter is not called horns. White matter is called columns. And that's because there are neurons running up and down in these white matter spaces. So I want you to envision that for one moment, that white matter neurons are coming out of this white matter to the point where you can see them kind of extending up and down. It's like highways that go up and down. So individual neurons are in these white matter columns. And what's great is that there's 13, 14, and 15. And white matter columns, you know what genius named these? These are also called the posterior, the lateral, and the anterior. This will become handy when we start to look at how information moves from the brain down the spinal cord. And if you say that to me on a case study answer, I'll say down what column of the spinal cord. So these are pretty much all of the structures. I guess there is one that I could mention right now. It's kind of an anomaly. Let's label it number 16. It's between the central canal and the anterior median fissure. And this is what is called a white commissure. A commissure brings information from left to right. So there are neurons that span this commissure, bringing information from one side of the spinal cord to another side of the spinal cord, right? We could draw them here, kind of like that. So it's not bringing information up, in, or out. It's just bringing information from one side of the spinal cord to the other, and that is called decussation. Decussation is the process of moving an action potential from the left to the right or from the right to the left.